Welcome everyone to our presentation, this very final presentation of air quality. This presentation will be given by me, Misha, Yuyi, Riekje and Rosalie. And we will be starting with a short introduction about the topic of our presentation and research. And that's mainly on the difference between man-made and natural borders at a highway, and how the concentration of particulate matter is influenced, and also how it behaves if you go a further distance from the source. We were very interested in this and set up the research questions of how the difference is between the man-made wall and the tree barriers. And we also did research for this, of course. That will be explained in a later part of the presentation. But first, Yuyi will now explain about the methodology and materials that we used in this experiment.
I'm going to talk about the materials and methods in our project. In our experiment, we need to use dial-loss particle counter to measure the number of particles, but this device is very sensitive to the wind, so we also take wind curves to measure the wind speeds. To get more accurate data, we choose a highway A12 near 8. This road will generate more PM pollution due to heavy traffic flow, which will be beneficial for our observation. We went to this road on Tuesday afternoon. Unfortunately, the weather was not good that day. It was raining for the whole afternoon, which will have some bad effects on the data. During the data collecting process, PM concentration and wind speeds were measured every 5 meters. Since the wind speed and concentration will change all the times, so we have to stay for 5 minutes for every point to measure the highest and the lowest value. So the final results we will discuss later. After finish the tree border measurement, we went to another place where it's just an artificial wall next to the highway, so we can compare the man-made wall with the tree border to find out if man-made wall is better to block the particle matter. Finally, for the module,
for the model, we wanted to use the Gaussian plume model, and we approached the road as a line source. But to use this model, we first needed the source strength. We determined the source strength by using the NSL monitoring tool. With this tool, you can calculate the emission. The emission was 5.2 micrograms per meters per second for the particulate matter 2.5. We added the source strength of 2 road segments together because the wind is perpendicular to the road, and then the source strengths add up.
Okay, so let me tell you something about the results that we got. So we plotted the distance versus the number of particulate matter that is bigger than 2.5, and we took both the maximum and the minimum values of these, and we plotted the wind speed, and you can see there is a decline, but at 25 meters it's going up because of the wind speed is also going up there. And we did the same for the 0.5 measurements, and again at 25 meters the concentrations are going up, but the 15 meters makes it also a little bit less reliable. And we also plotted the measurements of the man-made wall against the combined measurements of the tree walls, because we took 2 tree walls. And you can see that the man-made wall concentrations are bigger than the tree walls. And the same we did for the 0.5 measurements, both minimum and maximum values, and we see that the concentrations of the man-made wall are bigger.
The results of our Gaussian plume model experiment are shown in this figure. You can see that the concentration decreases linearly with the distance from the source, and the concentrations are notably quite low. We are not sure why this is the case. Now we will move on to the discussion, but before I will begin this part, it is important to understand that certain parameters have negatively influenced our measurements due to the weather and not being able to measure right besides the road. Our measurements were not entirely accurate, so keep that in mind. Now, if we compare the modeled situation with the measured situation, there's a couple of things that stand out. First of all, one is linear, the model. The other is not quite linear, which is the concentration. Also, the scale is very different. The modeled concentration are very small, and that of the measured are very, very large. We're not sure why this is the case. We think it might have been a mistake. So how do we explain that the modeled graph is linear, while the measured graph is not? Well, this effect is caused by the shelter belt. The shelter belt decreases, or at least affects, the wind speed behind it. This wind speed, again, has an effect on the concentration. You can see in the concentration graph that it decreases and then suddenly increases. This increase seems strange, but it's logical because after a while you step out of the effect of the shelter belt. The wind is not slowed anymore. It starts to increase, and the concentration also starts to increase. This effect we, of course, do not see in the modeled situation. A conclusion we could take from this is that the effectiveness of a shelter belt is dependent on whether you are in the described layer of the shelter belt. This is the layer where the wind speed is decreased.
In conclusion, trees on the road plays an important role in real life. They block out the noise, the pollutants from the highway. In our project, we find out that the tree border has better influence on preventing the particulate matter than man-made wall. Also, the PM concentration will decrease with the distance from the tree border. However, we don't have more time to get enough data to do further research. So maybe I think we can do more research about our project when we have time. Finally, it is really nice to work with each other, and I think we did a good job. So yeah.